best is they XOR it with the microseconds. There's no way we're going to know the microsecond that the web server started. But they're XORing the most variable data of the epoch with the most variable data microseconds. The fixed data, like what year, what month, what week it started, remains the same. Basically, it's being XORed. The fixed data remains fixed. So we end up with 12 bits that we can guess if we know within a 12-day period of when PHP started. And again, if we don't, we can send enough requests to get that. The other 20 bits is just microseconds XORed with the other variable data of epoch. We don't know that. Whatever. That's 20 bits. We've just reduced 12 bits of entropy in the random number generator. So let's look at S2. Process ID. Get process ID. That's 32 bits of entropy. Well, process IDs on Linux are only 15 bits long. So immediately you reduce 17 bits. And if you can execute PHP through any function, if you can execute a program like PS, if you can hit an Apache server info page or something like that, you get the entire 32 bits. We've now reduced the 64 bits down to 20 bits in the PRNG. We are now at a total of 40 bits of entropy from a 160-bit seed. From a 160-bit cookie for every cookie in PHP. That's awesome. But wait, there's more. We can take, normally you think, all right, well, we have 20 bits and 20 bits, so that's 40 bits. Well, we can actually calculate the PRNG, the LCG value, that 20 bits that we didn't know, separately. Separately means we calculate that 20 bits, and then the other 20 bits, that's only 21 bits. We can calculate with a time memory trade-off and code I created on your Defcon CDs, we can calculate that 20 bits in a matter of seconds. Seconds. That reduces the other 20 bits, and now we're at exactly 20 bits. The 20 bits of entropy from the microseconds that the user authenticated their cookie. That's 1 million cookies. On average, we'll be able to log in as him with 500,000 requests, which we can easily do in a day. 500,000. So I've done it. I've become R-Snake. So what can we do at this point? Well, first let's understand, how do we fix this? Make sure you're running a later version of PHP. Entropy is, I sent this over to PHP and they quickly released a patch. They added some more entropy. Or create your own session values. Use your own randomness. One of the great things about PHP is that it's very fast. It's meant to be fast. So they don't want to, it's also OS, basically cross-compatible. So they don't do too much that's very system level. Like they're not going to access dev-urandom because that's not on Windows, for example. Create your own session values or seed your own random number generator. Yeah, you don't need to understand crypto. Just use a strong seed that your system comes with. If you're running on Linux or BSD or something like that, use dev-urandom for your seed. Don't use the process ID. The attack is difficult to execute. It's much easier on social networks, where I spend most of my time, unfortunately. One thing to note, Facebook is actually not vulnerable. This is not an attack on Facebook. If you're familiar, Facebook has created their own version of PHP called hip hop. It's some sort of mash of PHP, turns into compiled C++. It's supposed to be much faster. I love Facebook. If you go on there, if you could just plant some crops for me in my farm bill, I'd appreciate it. So at this point, what do? I'm logged in as R-Snake. How am I going to meet this girl? She's happily boyfriended? I don't know what the word is. So using his cookie, I can now message her as him. So what do I say? Well, here's the thing. Why don't I send her to a malicious URL? Nambla. We're going to attack her network now. So this is your network. This is your network on drugs. We're going to learn a little bit about a network and a NAT here. This is a NAT. So a NAT, what it is basically a system that allows you to run multiple systems behind one public IP. In a nutshell, all of your computers behind the NAT will typically run on private IP space. This allows you to, typically your cable modem will only provide one IP address, so you use a router which contains NAT software, and that will allow all your network devices to run behind the NAT. It also is somewhat of a firewall. It prevents people from accessing services and ports that you have running on your computer, whether you know it or not. So when you go behind a NAT and you're running, say, Apache on port 80, no one can connect to you except internally on your network, unless you go to the NAT and you enable port forwarding or DMZ or something else. Well, let's talk about something that some of you may have heard recently called cross-protocol scripting, XPS. The cool thing about this is HTTP servers can run on any port. This means the browser will allow you to communicate to other HTTP servers on any port. But HTTP is a new line-based protocol. What that means is each line has some data, rather than some weird, let's say, XML formatted data or a binary stream of some sort. But there are other protocols that are also new line-based. So what we can do is we can actually communicate with a different new line-based protocol, like IRC. IRC is a great place. It's good people. So this is what an IRC connection looks like, just so you can tell really quickly. I telnet to a reputable server like FNet. I log in. I basically say my name's Sammy. I respond to a ping request if they have one, and then I join a channel, and I find out where I can get WinNuke. It doesn't work anymore. So if anyone has a version that works, please send it to me. This is how we do an IRC client on the web. What's interesting about this is I create a malicious page that has this code running on the page. You visit my malicious web page. Now, your client connects to the IRC server. Your web browser thinks it's an HTTP server. And what it does is it sends the HTTP request with the post data of my IRC data. Now, the IRC server says, well, I don't understand this HTTP request. I don't understand this line. Oh, I understand this. I understand join pound hackers. I know what that means. I'll interpret that. I'll just ignore all your other stuff. And at this point, I'm making your IP address connect to the IRC server. Now, this can be used for SMTP, for example. Spammers have actually been using this for years and years, and it hasn't been really well known. But they've been basically making people's browsers become spam servers. You visit a page, and without you ever seeing, on the back end, there's a form that's connecting to an HTTP server on port 25 and auto-submitting that form, and then basically you're now sending Viagra spam. Why you're going to Viagra site, I don't know, but it's what they have on the back. So this is what an HTTP post looks like. You see basically all the HTTP headers that your browser is sending, and then you see the IRC data. Again, the IRC server ignores the data it doesn't understand until it hits the data it understands. So why am I bringing this up? I'm going to talk about something called NAT pinning. Yes? NAT pinning. It's like XPS over times 9,000. So what is NAT pinning? Well, here's the thing. Your web browser was confused. It thought it was communicating with an HTTP server, but it was communicating with an IRC server. So NAT pinning takes this one step further, and basically, it makes the router also confused and thinks that it's communicating with a different protocol. So now your router thinks it's communicating with IRC, your browser thinks it's communicating with HTTP, and they start doing different things. What can we do with this? Well, let's take a look at a malicious server. That was supposed to say HP. I don't know what happened. So you have your system, your network devices behind your NAT. You have a malicious server that you're going to hit a website. You're hitting a web URL on that malicious server. Now, if you're familiar with IRC, there's something called a DCC. It's basically how porn is sent over IRC. It's great. It's a great protocol. Basically what a DCC is, it's a direct client connection. So when you're communicating with an IRC server and you're chatting with all the other really cool people, and you say, you know what, I want to send you this file, so connect directly to me. I don't want the server to, there's no point of the server bridging this file or this chat, so we'll connect directly. The way that works is you send a message to the person and you say, hey, I want you to connect back to me on this IP address on this port. Now, years ago, routers didn't understand this message. It was just TCP traffic. And what would happen is if you didn't have that port opened or forwarded to yourself, then the connection would never establish. People complained, this broke all sorts of things. It broke IRC, DCC, it broke FTP, it broke SIP. So routers got smart. They started developing software that would actually watch the traffic, look for messages like this, the private message, Sammy, DCC chat me. And if they saw that message, then they would say, oh, a client on my network is trying to get a file sent. So I'll port forward that port back to them. Well, if you recall, they're assuming that you're a valid client that said, I want to do this. I actually want this person to connect back to me. But you visited my malicious website, and your browser sent this data. Well, what if I put that DCC message in the browser, in the JavaScript submit? Now you visit my website. The website submits that malicious form to just some random server, and it says, I want you to connect to me on port 22, and port 80, and port 443, and 25, and 21, and 23. I've now just port forwarded every port I want to attack you on just by you visiting my website. That's it. The browser has no idea what's going on. It's just filling out its request, and I am attacking you on every single port. Here's the code. It's also on your CD. Have fun. So this is really cool. Now, once the XPS stuff basically became big, the browser started working on blocking certain ports. They said, you know what? You shouldn't be communicating on port 6667. If you're running a web server on there, you're stupid. Choose a different port. So they started blocking ports. Now, the interesting thing about ports is their 16 bits is the size of a TCP or UDP port. Now, if the browser says, I'm not going to allow connections on port 667, does this port match 6667? No. Just overflow it. So if you add another bit and you add 65,536 to it, you get this bigger number, right, 72,203. Your browser says, oh, that's not 667. This will go fine. It gets sent to the TCP stack, which then shortens it, and now you have 6667. I did not think of this. It was actually the respectable security group, Goat-C Security, that came up with this. Very good people. Very awesome. Very awesome. So at this point, Anna has clicked on my link. Wow. And now I've attacked her ports. So what did she have open? Well, a lot of OS X systems have a web server running by default. She was working on her website. It's so cute. So I connected back to her port 80 and saw she was making her own website about Team Jacob from Twilight. I love Twilight. Now I know how to get her. I'm just going to win her over. Here's the thing. I'm actually on Team Edward, but I'm not going to tell her that. So when I see her, I'm going to say, I'm on Team Jacob. So how do you stop NAT pinning? Well, there are so many ways that you want to have multiple layers. So you want a strict firewall. Try to make it as strict as possible if you can. If you don't expect people using IRC on your network, block it off entirely. If you don't expect people being able to send stuff, block off. You can actually turn off UPnP and other protocols that allow this type of thing to happen. Client side, run up-to-date browsers. WebKit was vulnerable to the port overflow. I believe they're resolved now. Other browsers might still be vulnerable. I'm not sure. Make sure you're running up-to-date browsers. Use NoScript if you're using Firefox. That'll block all sorts of types of things. When I released NAT pinning, NoScript a day later added protection in. Run a local firewall if you can, like Little Snitch. I mean, really, we all understand security is not just one level of security. You basically have to use multiple layers of protection, like I would with Anna. So at this point, I know what she's into. I know how to win her over, I think. So I'm going to send her a message to go to another malicious website. I'm going to say, you know what? This guy, Sammy, he's a really good friend of mine. He's going to come over and take care of you. Check out his Twitter on Nambla/Twitter. So now, the moment you've all been waiting for. XXSS. This is awesome. This is actually really awesome. We're going to be talking about geolocation via XXSS. So how does this work? Anna visits my malicious site. She then, the XXSS scans her